Okay, everybody, what I want you to do is I want you to go, either the person in the room can go hand them out or nominate someone. We need worksheets 210, and then we need a worksheet that's called percent problems / proportions. So if you're at home, open up 210 and get ready also for percent problems and proportions. We're going to go over some examples from each. So I'm going to give you a few seconds to get that. Person in the room, if you need to pause the video, so that way, well, actually I'd be pausing the video. Okay, hopefully that is up and running. Okay, I also am on the Zoom today, but I thought I'd record this lesson so that way you can hear it and you can go back to it. So it's already on Google Classroom, but this way you're hearing it today in class, and you can go back if you need to a different day. So when you're at home working tomorrow, you can go back and do it. Okay, so 210. So remember, when you're on the Zoom call, you can always privately message me if you have a question, and then we'll go from there. Okay, so for 210, it says, tell which each percent change is an increase or decrease, then find the percent change. Round to the nearest percent. So we're going to round to the nearest whole number. Okay, so first thing it says, tell which either is an increase or decrease. Okay, I'm going to put a light on to see if that helps. Okay, well, if I'm going from 10 to 12, is that an increase or decrease? Well, it got bigger, so right away, you're going to put increase. Okay, to find the percent change, what you need to do, maybe make a little note at the top of your paper, is you need the change over the original or actual. Then that'll get you a decimal. So then you have to times it by 100 because you want a percent, and percent's always out of 100. So you take your change over your original or actual. Now, we're not going to worry about if it's a negative or a positive because we take care of that right here. It's an increase. So we know that that would be an increase percent. So we're not going to put a negative percent in here. We're just going to put a whole number. Okay, so if I went from 10 to 12, my change in that would be 2. So I'm going to put that on top. So 2 over. Okay, my original or my actual? Well, I have the original here, which is 10. So I'm going to put 2 over 10. Okay, this is when I hope you have a calculator. Some of you can figure out what 2 divided by 10 is. That's fine. So 2 divided by 10, 2/10 is 0.2. Okay, we should know that one. But when in doubt, put in your calculator like Mrs. Adrian just did. Okay, then I have to times it by 100. So times by 100, moving the decimal over twice. So really, if you can move the decimal without timesing by 100, you have to pick what's easier for you. So that is 20%. So going from 10 to 12 is a 20% increase is what that means. Let's do a couple more so you can get the hang of it. Number 4, original amount is 23. The new amount is 25. I better leave this so you can see that on top. Okay, so I need my change from 23 to 25. Remember, I don't care. No, first I should actually put increase or decrease. 23 to 25, is that getting bigger or smaller? It's getting bigger, so that's an increase. Okay, now remember, I don't care about negatives, so we're just gonna go with it. What's the change between 23 and 25? 2 over my original, which is 23. So you take 2 divided by 23, which gives you 0.08695, okay, whatever, times it by 100 or move the decimal place twice, bloop, bloop. Okay, and remember it said round to the nearest percent. So instead of 8.6, this would be 9%. Okay, so if I go from 23 to 25, that's a 9% increase. Okay, so I'm gonna let you take a break for a second, catch up if you didn't write it all. Okay, number 7, I'm gonna move up so that I know you can't see this, but it should be on the top of your paper. You're going from 38 to 45, increase or decrease? Well, that's going up, so that's an increase. Okay, difference between 45 and 38. So whatever 45 minus 38 is, that's 7. over my original, which is 38. So 7 divided by 38, press enter. You get 0.1842, okay? Times it by 100, move it over twice, bloop, bloop. 18.4, which rounded to the nearest whole percent is 18%. Okay, so that is how you do percent change. Okay, you got to think change means subtracting. What's the change in it? What's the difference between this and this? Change is a difference. So then you go over the original or over the actual. So the reason I say over the actual is because when you come down here, it says find the percent error in each estimation, round to the nearest percent. You estimate that a building is 20 meters tall. It's actually 23. So what's the change between the two? Now these we do not need to say increase or decrease, doesn't matter. We're just doing the percent error. So what's the change between 20 and 23? 3. Okay, it's over original or actual. Well, it says actual is 23. That's the actual height of it. So we're going to see how much we were off when we said it was 20. So we're going to put the 23 in there. 3 divided by 23. Press enter. 0.1304. Okay, make it into a percent, times it by 100, move decimal over twice. 13.0, round to the nearest percent, that would be 13%. So my estimation of that 20 meters, and when it was actually 23, I was off by 13%, which can be pretty significant, matters what job you're doing. Okay, so let's go to the back side. We're going to do 16, 17, and 18 together. It says a measurement is given, find the minimum and maximum possible measurements. Okay, so when you are measuring, there's always a chance that you'll have error because we're humans. We have human error. So what we do when we have that is we assume that we could be off by a half a unit of whatever we measured to. So if I measured to a half a foot, I could be off by a half of a foot, which would be 0.25. Okay, so if I measured to the nearest inch, I could be off by another half an inch, higher or lower. Okay, so 16, it says a nurse measures a newborn baby to be 22 inches long, which this happens a lot because you take them and then you go back when they have another check and then all of a sudden they're not 22 inches long. And you know your baby didn't shrink in that month that they were not at the hospital. But again, nurses error compared to, and then just error between two nurses. So it says a nurse measures a newborn baby 22 inches long to the nearest inch. So we know we're doing it to the nearest inch. So she could be off by a half of that, which is a half of inch, either shorter or longer. So if I was a half an inch shorter than 22, that would be 21.5 inches. So that newborn baby could be 21.5 inches, anywhere in between there. Oh, and then all the way up to a half inch higher, which would be 22.5 inches. So this is the range that that baby would probably be in. So a bag of apples weighs 4 pounds to the nearest pound. Okay, so we can be off by a half of a pound. So lower than 4 is 3.5 pounds. Okay, and then all the way up to higher than 4, a half a pound higher, so 4.5 pounds. Okay, fencing comes in lengths of 8 feet to the nearest foot. Okay, so they could be off by a half of that unit, so a half a foot. So half a foot lower than 8 would be that 7.5 feet, all the way up to half a foot higher, which is 8.5 feet. So that's the range, the minimum and maximum, okay? 19 through 24, again, is just percent change. That's what you did at the front of the page in the beginning. Okay, let's try 25. Now, if these are confusing to you, the good news is this is on a video. You can watch it again. It's already on Google Classroom. It's written in some material, so it's under week 11, week 9. That's what we're in. Okay, 25. The measure dimensions of a shape or solid are given to the nearest whole unit. So they could be off by a half a unit, either smaller or higher, okay? Find the greatest percent. Oh, we're skipping that one. Sorry. Well, let's go back up to 25 first. The measured dimension of a rectangle are given to the nearest whole unit. Again, could be off by a half a unit, either low or high. Find the minimum and maximum possible areas. So now I need to remember what an area of a rectangle. Remember, area of a rectangle is length times width, or width times height, however you want to say that, okay? So if I have 4 centimeters by 7 centimeters, okay, let's say we're low. okay? We could be off by a half a unit because we went to the nearest whole unit. So that would give me 3.5 centimeters, correct? Okay, and if I want to find the area, I take the length times the width. Well, let's say, for the sake of argument, that we're, again, low. We could be off by a half unit on 7, so that would be 6.5 centimeters. So I need to find out what that area is. So I just need to take 3.5, so 3.5 times 6.5, press enter. I got 22.75, and then remember it's an area, so that's centimeters squared. Okay, so that's the minimum I could be off. It could actually be that it could actually be 22.7. Okay, now we're gonna do the maximum. So if I was high on 4, I could have 4.5 centimeters times high on 7, 7.5 centimeters. So take that 4.5 times that 7.5, and that gives me 33.75 centimeters squared. So that's the minimum, that's the maximum. Okay, if that confuses you, you can go back and listen to that again. Okay, now 28 uses everything that we did on 25, but now it's changing to percent error. So we need to find these minimum and maximum values, and then we need to find the percent error from that. So remember, percent error is change over original or change over actual. Okay, so here we go. All right, so if I am measured into the nearest whole unit again, okay, so I could be off by 1/2 foot either way. Now, if you think about it, if I'm off by 1/2 foot shorter and I'm taking the perimeter, that's going to be the same amount off as if I was a 1/2 foot longer. So you get to just pick either smaller or higher. It doesn't matter which one you do. So let's do the smaller one. So if I'm doing 127, a 1/2 unit lower than that is 126.5. Now I want to find the perimeter. Remember, perimeter is adding all the distance around. So you have to think. So this one says perimeter, this one says area, and this one says volume. So volume is, remember, length times width times height. So area is length times width, and perimeters, you're adding all the sides. So you actually have to remember, what operation are you doing? Well, this is perimeter, so I need to add all my sides up. So I have 2 lengths at 126.5. So 126.5 plus 126.5, plus now I have 2 widths. And remember, I was off a 1/2 unit short. So 210.5 plus 210.5, which gives me, if I type that into my calculator, it gives me 674 feet. So that's my perimeter if I was off. Now we're going to do the actual of what we thought we did. So we have the 127 and the 211. So I have 127 because I have a length, plus another 127, another length, plus another width, 211, plus another 211. So that's what I think it is. That's my actual. That's what I assumed it was. So that adds up to 676. Okay, not done. So we have an actual and we have how much we could be off by. So percent error is the change over the original. So what's the change between these two? 2 feet. So 2 over the original. So the one that you thought it actually was, which is the 676. Remember, divide that. So 2 divided by 676. Okay, you should get a decimal, a really small decimal, because if you're only off by 2 feet and you're measuring 676 feet, that's pretty dang good, I think. 0.00295, okay? Remember, multiply by 100, because this is a percent, so move the decimal over twice, or multiply by 100. Well, 0.29, we'll round that up to 0.3%. So you're only off by 0.3%. That's pretty dang good, I think. So if you're confused, you can watch that again. That's the good news. Now let's switch over to this worksheet, which is actually a review of the stuff that we just did. So you should have 2 worksheets in your possession. You should have 2 8 and 2 9, and I'll tell you what to do with that in a second. But right now I want you to look at the percent problem worksheet. So remember, percent problems, you can either do it as a math sentence. So you need to remember that this multiply is its equals. And remember, when you do it that way, you have to change your percent, decimal, vice versa. Decimal into percent, percent into decimal, okay? Or you can do it Mrs. Adrian's way, which I love, is over of equals percent over 100. Okay, then you don't have to do anything. It's all done for you. It's already ready. So you just cross multiply and you solve. So we're going to do one the math sentence way, and then we're going to do one the proportion way. Okay, so number one, we're going to do the math sentence way because I don't like that one as much. So I'm going to get it done with. What percent? So I don't know the percent, call it x. Of is multiply. 29 is equals 3. Remember, we're solving for x. So how do I undo multiplying? You got to divide. Okay, so I take 3 divided by 29, press enter. This is going to give you 0.010344. Remember, now this, it says what percent, so you got to turn that percent back into a percent. You got to multiply by 100. Only when it asks for what percent. So percents, you either have to make them into decimals or you got to turn them back into percents. So you have to look and see what they're asking you. So multiply by 100 or move the decimal twice. And then it says to the 10th or 10th percent. So we have 10.3, that 4 is not gonna make that 3 go up. So we have 10.3%. Now the reason I put the percent sign on this one is because it asks what percent. So like when I get down to number 4, we already have the percent, so don't put the percent sign on there. Some of them are asking for parts, some are asking for wholes, and some are asking for percents. So sometimes you'll hear someone say parts and wholes and percents, okay? That's what this is. Number 5, we're gonna do Mrs. Adrian style. So let's do that. Is over of percent over 100. Well, I have the percent, so 28 over the 100. And then I have is over of. Well, I have of 63, so I'm gonna put that on the bottom because of always goes on the bottom. Is what, so I'm gonna put an X there. Then just cross multiply. So I have 100x equals whatever 28 times 63 is. Got a calculator right here. 1,764. Divide by 100. Okay. So moving that over twice, so 17.64. Remember, round to the 10th, said 10th or 10th of a percent. So that 4 is not going to change that 6. So 17.6. Okay, so that should be a review. That's what you just finished. If you need more examples, you need to watch that again. Or you can watch the video from 2.8 and 2.9, and you can watch those examples. So there's plenty of examples to watch. Okay, let's look at the backside. The backside is just solving proportions. So just cross multiplying. Now remember, when there's 2 things in there, we have to add that parenthesis in. So we're going to do number 13. So it's 7 times n plus 2, but that n plus 2 is an entire quantity. So you need to put it in parentheses. So 7 parenthesis n plus 2 equals 4n. Okay, now distribute. So we have 7n plus 14 equals 4n. Keep solving for n, get n by itself. Well, I'm going to move that 7n over. So I have 14 equals negative 3n. Yep. Divide by negative 3. And then just like the front, we're going to round to the nearest 10th. So 14 divided by negative 3 is 4.6 repeating. So that's 666, whatever. Okay, I'll get rid of the repeating sign. Okay, round to the nearest 10th. So 4.7 is n. So n is 4.7. Okay, one more of those, just so you're ready. Let's do 17. If you don't feel like writing these down because it bothers you that it's out of order or you don't have the paper in front of you, you can watch, but you still need to do it. Okay, we're gonna cross multiply. 8 times that quantity, so 8 parenthesis p minus 7 equals 9 parenthesis p plus 10. We got to distribute both of them. So we got 8 times p, which is 8p, minus 8 times 7. Remember, if you are unsure, it is okay to use a calculator. 7 times 8 is 56. Okay. Equals 9 times p, which is 9p. 9 times 10, 90. Get all your p's to one side, all your numbers to the other. Well, I'm going to move that 8p over just because I don't feel like dealing with a negative this time. Okay, I'm going to try to do 2 steps in one. I think you guys can handle it, but if you can't do 2 steps, that's fine. I'm also going to subtract the 90. So I have a negative 56 minus a 90. So remember, that's like you borrow $56 from me, and then you borrow another 90. So what do you owe me? you owe me 146, so it's negative 146. Okay, equals P, because it's 1P. Well, I wanted P, so I am actually done. And remember, if in doubt, you can always plug this back in for all your P's, and then that should equal what's on the other side. So when in doubt, you can do that. Okay, so that's the review worksheet. So when you're at home tomorrow, you have 2 worksheets to work on. The 210, which we did quite a few of those together, okay, and the percent problems / proportion worksheet, okay? So people at home, you know what to do. People at school, you know what to do. Now, you're wondering, what are we gonna do with worksheets 2.8 and 2.9? We didn't correct them. What are we gonna do? Okay, I actually put a Google form under your classwork. So I picked random questions from worksheet 2.8 and 2.9. So right now I want you to get out 2.8 and 2.9. And you need to finish typing in your answers into that Google form for those. I picked 16 random questions from them. So it'll say 2.8 number, blah. Okay, so it's like number 5, whatever. So then you type in the answer. Now, you are only typing in the answer. You are not typing in labels. We're not going to worry about labels. We're typing in just numbers. Okay, so use a decimal if you need to. If it's like to the 10th, so 26.7, that's fine. Okay, but just numbers. So you're gonna need your worksheets 2.8 and 2.9, and you're gonna do that in the Google form, and you're gonna do that right now because that is due by 3:15 today. So you are gonna do that now in class because you should have had those worksheets done. Okay, I'm here if you have any questions.